Introduction to Information System Control. In this video, we are going to see about Introduction to Information System Control. Good controls make good business sense. The controls are measures taken to ensure effective management control. The controls are constraints and other measures imposed on a user and can be used to secure systems against risks or to reduce damage caused to systems, applications, and data. General controls have great significance in the sense that application controls and user controls cannot be effective if the general controls are weak. General control measures are applicable to all applications and data resources. General controls consist of physical and software controls. General controls affect all computer applications and includes procedures to control. Development of new programs and systems. Changing of existing programs and systems. Access to programs and data. Computer operations. General controls, operating system controls. In this video, we are going to see about general controls, operating system controls. Computer software can be divided into two categories. System programs, which manage the operation of the computer itself. Application programs, which perform the actual work as per user requirements. The most fundamental system program is the operating system, which controls all the computer's resources and provides the base upon which the application programs can be written. An operating system is a group of programs designed to increase the efficiency and effectiveness of the computer in its day-to-day operations by reducing setup time through an automatic program sequencing and selection. Operating systems can be termed as resource managers. In general, an operating system serves as an interface between application software and hardware. Operating systems perform the following tasks: handling input from the keyboard, handling output to the screen and printer, handling communication with the use of a modem, controlling input or output with all bus devices such as a network interface, control objectives of operating system. The operating system must protect itself from users. User applications must be independent of operating system so that operating system remains unaffected even after the execution of user application programs. The operating system must protect users' programs from each other so that one user's program should not be able to damage other users' program data. The operating system must protect user program with its own independent modules by keeping each module in a separate location. The operating system must be protected from its environment, for example, power failure. It must have the ability to recover itself after a disaster. Operating system security. In this video, we are going to see about operating system security. The operating system security framework comprises of security policy, procedures, controls, and human. This paradigm determines who can access the operating system, which resources they can access, how they can access, what actions can be taken against them if they are found violating the security. The security components required to secure operating system are access control. Access control check on authorization. Access controls are measures taken to ensure that only those who are authorized have access to a computer or network or to certain applications or data and actions they can take. Access can be controlled through a combination of the following measures: logon procedure, password control, access token, access control list, discretionary access control list, that is DACL, logon procedure, password control. The most commonly used for determining access to systems, applications, data files, or a network server is the user's ID and password. A password is a secret code entered by the user to gain access. As the user is a source of vulnerability, every user represents a way to access the system. While initiating the process, a dialog box requesting the user's password appears on the screen. The user enters a user ID, then asks for a password. If the password entered by the user matches with the one assigned to the user, access is allowed. If not, the access is denied and the user may try again. After a specified number of unsuccessful attempts, the user is logged out from the system. If the password is easy for the user to remember, it is likely that an intruder could guess the password just by knowing a little about the user. To make the process more secure, the following guidelines should be followed. Do not leave the password out in the open. Do not write your password at any place. Choose a password with at least 6 letters. Choose a password that is not an actual word in the dictionary. Do not choose a password that is obvious. Obvious passwords could be guessed after a few trials. Preventive measures include the following: limiting new passwords to those that pass a series of quality checks. Password should be changed at periodic intervals. Access token. If the logon is accepted, a process is created for the user and an access token is associated with that process object. The access token includes a security ID, which is the identifier by which the user is known to the system for purpose of security. The access token serves the following purposes. It keeps all necessary security information together to speed access validation. It allows each process to modify its security characteristics in limited ways without affecting other processes running on behalf of the user. Access control list. Access control list is a register of users including groups, machines, and processes that have been granted permission to access specific information resources, including data, information, and transactions. Access is permitted for users to read, copy, write, delete, execute. Various users may need different types of access to a file or directory. Discretionary access control list, that is DACL, determines which users groups can access a particular object and for which operations. It consists of a list of access control entries. When an object is created, the creator or owner of the process can assign its own SID in its access token. The creating process cannot assign an owner which is not in the current access token. Subsequently, any process that has been granted the right to change the owner of an object may do so, but again with the same restrictions. Threats to operating system integrity. In this video, we are going to see about threats to operating system's integrity. A total approach to operating system security involves both accidental threats and intentional threats. Accidental threats deal with securing the operating system against failures, such as hardware failures that cause the operating system to crash. It is always easier to protect against accidental threats than to protect against intentional threats. Intentional threats to the operating system may be in the following form: unauthorized reading of data or theft of information, unauthorized modification of data, unauthorized destruction of data. Intentional threats to the operating system are common for various reasons. These are violation of users' privacy, financial gains, illegal access to data, using programming skills for fun, To protect the system, security measures are taken at the following two levels: physical, users. Physical, the site or sites containing the computer systems must be physically secured against entry by intruders. Users. Users must be screened carefully to ensure that the chance of authorizing a user who then gives access to an intruder is reduced. Controlling against viruses and other destructive programs. In this video, we are going to see about controlling against viruses and other destructive programs. The first step in the provision of appropriate computer security is to identify the potential threats or attacks to the computer systems. The term attacker is commonly used to refer to a person or program trying to obtain unauthorized access to data or a resource of a computer system. An attacker may be a threat to computer security actively or passively. An active attack generated by viruses causes harm to the system, while the passive attack does not. Therefore, passive attacks are inherently undetectable by the system and can only be dealt with by using preventive measures. However, active attacks can be combated by a combination of prevention, detection, and recovery techniques. Passive attacks. In passive attacks, the attacker somehow tries to steal unauthorized information from the computer system. Commonly used methods of passive attacks are described below: wiretapping. Under this method, attackers attempt to read stored files, message packets passing by on the network, other processes, memory, etc. without modifying any data. To control this type of attack, access control mechanisms are used to prevent unauthorized reading of stored files and other processes' memory contents, and message encryption is used to prevent eavesdropping of messages transmitted over network links. Data leaking. Under this method, attacker removes copies of confidential data either on magnetic medium or on printed copy from within a system without any trace with the help of an accomplice. Interferencing. In this method, attacker tries to draw some interference by closely observing and analyzing the system's data or the activities carried out by the system. Masquerading or Trojan horse. In this method, an attacker masquerades as an authorized user or program to gain access to unauthorized data or resources. Penetrating security in this manner is also known as Trojan horse attack. Active attacks. Active attacks interfere with the normal functioning of the system. Active attacks are more malicious than passive attacks. Some commonly used forms of active attacks are viruses. A computer virus is a piece of code attached to a legitimate program that, when executed, infects other programs in the system by replicating and attaching itself to them. The virus programs usually attach themselves to the following types of executable files having extensions as an.exe or .com program file, the .ovl, that is overlay program file, the boot sector of the disk, a device driver program. Virus spreads because every time an infected program is executed, it tries to infect more programs. Virus does not infect an already infected file in order to prevent an object from growing ever longer. This allows the virus to infect many programs without noticeably increasing disk space usage. Worms. Worms are programs that spread from one computer to another in a network of computers. Logic bomb. A logic bomb is a program that lies in wait for unsuspecting computer users to perform a triggering operation. It lies dormant until some triggering condition causes it to explode. Controlling audit trail. In this video, we are going to see about controlling audit trail. Audit trail is a means for identifying the actions performed on data as it moves through an information processing cycle from source document to output or report, or tracing the output to its source of derivation. Objectives of audit trail. Audit trail support the security objectives in the following ways. Fear of detection of fraud through audit trails indirectly discourages employees from committing frauds. Audit trails help in detecting unauthorized access. They can also be used to determine accomplished and attempted but failed attempts. Audit trail can be used to report on changes in system performance due to virus. Implementing an audit trail. Audit trail information helps in uncovering undesirable acts from innocent mistakes to premeditated fraud. A typical audit trail generally contains the following information: request, that is source text, terminal from which the operation was invoked, user who invoked the operation, date and time of the operation, relational variables, tuples, attributes affected, old values, new values. Data management controls. In this video, we are going to see about data management controls. The objective of database control is to ensure that only authorized users can perform authorized activities at authorized times. Data management controls are designed to ensure that correct data is stored and accessed. Data security refers to the protection of data against unauthorized disclosure, alteration, or destruction, whereas data integrity means protecting data against unauthorized uses. Data integrity refers to the accuracy and validity of the data. Secrecy. Information should not be disclosed to unauthorized users, that is, users may be authorized to access only a particular class of data and not all the data. User may not be allowed to modify them. Integrity. Integrity involves that only authorized users should be allowed to modify the data. Availability. Authorized users should not be denied access. To achieve these objectives, a clear and consistent security policy should be developed to describe what security measures must be enforced. Controls over database management can be divided into two categories: access controls, backup controls. Access controls. In this video, we are going to see about access controls. A database for an enterprise contains a huge amount of information and generally has several groups of users. Most users need to access only a small part of the database to carry out their task. A mechanism should be provided by DBMS to control access to data. Access control acts as a barrier to prevent unauthorized access of data. Access control mechanisms enforce rules regarding who can perform what operation or who can access which data. Access is the ability to do something with an information resource. Authorization is the means by which that ability is explicitly enabled or restricted. Access control is the foundation upon which all of the other information protection procedures will be built. The access control mechanism must determine who is authorized to access the organization's information processing system, how the users will be authorized, when the user can access the resources. Access can be controlled in the following ways: identification and authentication of accessor. The process of identification may involve several parameters such as personal identification of accessor, location of the accessor, time and delay of access, frequency of access, etc. Personal identification may be performed with the help of passwords, voice prints, fingerprints, signatures, etc. There are two main approaches to access control: discretionary access control. Discretionary access control is based on the concept of access rights or privileges or mechanisms for giving users such privileges. A privilege allows a user to access data object in a certain manner, for example, to read or to modify. Mandatory access control. Mandatory access control is based on system-wide policies which cannot be changed by individual users. Mandatory access control mechanism is susceptible to Trojan horse schemes whereby an unauthorized user can trick an authorized user into disclosing sensitive data. Database authorization table. Database authorization table associates with each file and directory an access list specifying the username and type of access allowed for each user. When a user requests access to a particular file, the DBMS checks the access list associated with that file. If that user is in list, the access is allowed. The database authorization table contains rules regarding actions a user can take. User-defined procedures. A user-defined procedure involves asking of series of personal questions such as user's grandmother's name in addition to the password which only a legitimate user is likely to know. If the user answers these questions and the answers match with the already stored answers, the user is allowed access. Data encryption. Data encryption is a technique of storing and transmitting data in encrypted form. Biometric controls. Biometric controls are security measures provided by computer devices which measure physical traits that make each individual a unique. This includes fingerprints, voice verifications, signature dynamics, etc. Backup control. In this video, we are going to see about backup control. Data loss may be caused by natural disasters, computer viruses, or by human errors. The easiest way to protect against loss of data is to duplicate all data at periodical levels. This process is referred to as data backup. How often the data should be backed up depends on how frequently the data is changed. Some systems have built-in automatic backup programs. The data may be copied on inexpensive storage devices such as magnetic tapes. The file security. A computer file is similar to a manual file. It contains a set of records systematically arranged so that they can be changed or deleted and other records can be added. Data can be arranged in files in a variety of ways, but a hierarchical approach to organization is generally recommended. A data element is the smallest unit of information stored in a computer file. Each single element is used to represent a fact such as employee's name. Data elements are physically arranged as fields in a computer file. Their length can be fixed or variable. Data element codes often function as links to other sets of records. The next level consists of records in which several data elements are grouped together to form a record. The same data elements may be used in more than one type of record. A record consists of a set of logically related data elements. There is one record for each item contained in a file. Next records are stored in files. A file consists of a set of logically related records. Each file consists of a variable number of records and therefore files are not necessarily of equal size. Files may be of several types such as master file, transaction file, summary file, etc. Finally, various types of files form a database of the organization. The physical layout of the files can be organized in the following ways: sequential organization, direct organization, indexed sequential organization. The master files on magnetic disks and tapes can be reconstructed by employing the following techniques: magnetic disk or direct organization. In case of magnetic disk or file backup with direct and indexed sequential organization, file security is carried out in the following manner. In case files are organized in direct or indexed sequential organization, there is no old file, the old and the new being the same. When old master file is updated, it becomes new master file. A common procedure for supplying a backup is to copy the entire contents of a disk to magnetic tape at the end of each working day. Magnetic tapes or sequential organization. The procedures followed in reconstructing files in the case of magnetic tapes or sequential organization is referred to as generation data sets. Generation data sets consist of copies of at least the 3 file updates, which are stored generally in fireproof vaults to provide backup and security in case problems arise in processing. The first copy, called the son, is a lost copy of the old file. The second copy, the father, is the next to last copy of the old file. The third copy, the grandfather, is the copy preceding the next to last. Under this system, the son copy is stored in a vault located adjacent to computer operations. The father and grandfather copies are stored in a fireproof vault at a remote site away from computer operations. In case of any mishappening to the computing equipment and even the first copy of the file, 2 additional backup files are available on the basis of which a file can be rebuilt. File protection. In addition to user identification and authorization procedures, the following steps should be developed to restrict access specific data files. Labeling external and internal files to identify the type of information contained and security level required to access them. Restricting access to related areas containing data files. Establishing controls relating specifically to software, hardware, and procedures that will aid in restricting access to online files to only authorized users. Backup controls in a database environment. Data sharing is the fundamental objective of the database approach. Therefore, controls designed to protect against human tampering with stored data are often more elaborate. With online data access, for example, it becomes possible to retrieve and review records from a file from a computer terminal without changing the contents of the file, provided the person accessing data is authorized to do so. The problem arises when confidential data are accessed by employees lacking proper authorization. Security codes have been designed to deter improper access to computer files. Generally, an individual at a terminal must use an account number and a password before gaining access to a file. Due to centralization of data, a minor disaster in a database can affect many or all users. In that event, organizations need to rebuild this database to bring it to the status of pre-failure. This can be achieved only if databases are adequately backed up. Most of the mainframe DBMS have a backup and recovery system which have the following feature: backup, transaction log, checkpoint, recovery module. Organization structure controls. In this video, we are going to see about organization structure controls. Organization structure controls are procedure controls or methods which specify how the information services organization should be operated for maximum security. They facilitate the accuracy and integrity of computer operations and system development activities. One of the most important measures used to prevent abuse of criminal inside jobs is the separation of duties. Separation of duties establishes an environment in which different people are in charge of different activities to allow checks and balances and minimize the possibility of criminal behavior. To succeed, policies must be developed for separation of duties during system development and maintenance as well as during the system's operation. The principle of separation of duties requires that the duties of system development, computer operations, and control of data and program files be assigned to different groups. Separating system development from computer operations. In this video, we are going to see about separating system development from computer operations. The separation of system development, both new system development and maintenance, and computer operations activities are of great importance. Menus, access codes, passwords, and other security measures are incorporated during the development of a system. If the operations staff is involved in the system design, may gain knowledge of the application's logic and control parameters and access to computer systems, and may be prompted to make unauthorized changes to the system during its execution. Merging of these two functions invites frauds. Therefore, duties and responsibilities of data entry personnel, computer operators, application programmers, system analysts, and technical staff should be separated. Separating the database administrator from other functions. In this video, we are going to see about separating the database administrator from other functions. Since the databases of an organization are used by many different applications, they need to be centrally coordinated and controlled by a data administrator function. Data administration involves the establishment and enforcement of policies and procedures for managing data as a strategic corporate source. Database administration involves enforcement of the use of the common data dictionary and standards for database use and security. The responsibility for maintaining a library of data files should be assigned to the database administrator. Database administrator should not be involved in system development. Database administrators should work independent. Separating new system development from maintenance. In this video, we are going to see about separating new system development from maintenance. The system development function is performed by system analysts and programmers. The programmers who code the programs according to the design specification developed by system analysts should not be assigned the job of maintenance during the maintenance phase of system development lifecycle. Inadequate documentation. Inadequate documentation increases the potential for fraud. This is particularly true in companies that do not use case tools with automatic documentation feature. There may be two reasons for inadequate documentation. Documenting a system is not as interesting as designing, testing, implementing it. System professionals are often interested in doing new projects rather than documenting the one that has been completed. Poor documentation provides job security to the programmers. Where the system is poorly documented, it is difficult to understand, interpret, and debug by the person other than the programmer who has coded it. The programmer becomes indispensable and powerful. For a new programmer, it is costly and time-consuming to understand the complexity of the system. Program fraud. Program fraud refers to committing an illegal act by making unauthorized changes to program modules. When the original programmer of the system is given the responsibility to maintain the system, the risk of system increases. Separating the data library from operations. In this video, we are going to see about separating the data library from operations. Separating the data library from operations. Data library is the place which provides safe storage for the offline data files, which may be magnetic tapes or disks. Data librarian is responsible for the receipt, storage, retrieval, and custody of data files. The data files are issued to computer operators as per the system request by the librarian and are returned to the librarian for storage after the computer operators are thorough with those files. Librarians are responsible for maintaining and controlling access to the libraries and database of the organization. Separation of duties of data library from operations also ensures that many files and databases are protected from unauthorized access. System development controls. In this video, we are going to see about system development controls. System development controls ensure that a system is developed according to established policies and procedures. They also ensure that systems are developed within budgets, within budgeted time, security measures are duly incorporated, and quality and documentation requirements are maintained. System development controls involve the following activities. All systems must be authorized. Requests for system development should be reviewed formally before authorization is given. Each system development request should be subjected to a formal notification and scheduling procedure. This requires that such new system requests should be made in writing by users to the managers who have authority to evaluate and approve or reject a request. This approval should contain the approval of estimated time, cost, persons, and other resources required to carry out the task. Users must be involved. The users must be involved in the system development process because the information systems are designed to meet the needs of its users. To accomplish this goal, the users must explain their needs to system analysts. In addition to this, the users must determine whether the system that is developed meets their needs. Therefore, users must be involved at various stages of system development process. Appropriate documentation. The various activities associated with system development should be properly and adequately documented. Without proper documentation, it becomes difficult to operate, maintain, or use the system. Documentation should show how a system operates from both a technical and a user standpoint. Technical documentation includes system flowchart, file layouts, list of programs, program structure charts, job run schedules, backup or recovery procedures, file access procedures, hardware or operating system requirements. On the other hand, user documentation includes output layouts, input forms, instructions for using reports, workflows, error correction procedures, processing procedure narrative, responsible user contact, data input instructions, etc. Documentation serves as a method of communication among the people responsible for developing, implementing, and maintaining a computer-based system. Documentation is extremely important in diagnosing errors in the system and making changes, particularly when the end users or system analysts who developed a system are no longer with the organization. Internal auditor participation. In a manual information system, the audit trail is quite visible and easy to trace. However, in computer-based information systems, the form of audit trail is completely changed. Information in the form of visible records is no longer available to the auditor in computer-based information systems. It is recorded on media that can be interpreted by machines. Moreover, real-time transaction processing systems have increased the invisibility of the traditional audit trail. Paper documents and historical files are frequently eliminated when remote terminals and direct access files are used. These developments make the auditing of such system a complex but vital assignment. Therefore, internal auditors should be included on the project team of all major system development projects. The internal auditor can ensure that adequate controls are designed into the system being developed. Testing. Hardware devices, software, and information processing procedures must be tested rigorously before they are implemented. Programs must be tested using test data, and the results of the test then should be compared with predetermined results to identify programming and logic errors. Programs should be subdivided into levels of modules to assist their development, testing, and maintenance. Program testing usually proceeds from higher to lower levels of program modules until the entire program is tested as a unit. Testing should occur not only during the system implementation phase, but throughout the system development process. User test and acceptance procedures. Testing produces copies of displays, reports, and other outputs. These should be reviewed by end user of the proposed systems for possible errors. The proposed systems should be rigorously tested by a team consisting of users, system analysts, and the internal auditor before being accepted. The acceptance of user must be documented. Training. Users should be trained adequately to ensure that they are aware of security concerns and to understand how these concerns are related to rules and procedures. They should be aware of the signs of suspicious activity and the procedures to be followed for reporting that activity. Training should be used to reinforce the value of security consciousness in all employees. Training programs should stress upon the individual employee's responsibility for information security, proper use of sensitive information, and procedures for reporting potential violations. System maintenance controls. In this video, we are going to see about system maintenance controls. The maintenance of existing systems is an essential but time-consuming activity. System maintenance involves modification and alteration of existing systems result from changes made in a computer system, tax factors, poor system performance, changing user requirements, etc. Maintenance authorization, testing, and documentation. Requests for system maintenance should be reviewed formally before authorization is given in the same manner as with system development. Each system maintenance request should be made formally in writing. This means that each maintenance request should contain reasons for maintenance. The approval should contain the approval of estimated time, cost, persons, and other resources required to carry out the task. Maintenance activities should be treated on the same lines new development. Changes in the system must be properly documented, which includes reasons for change and degree of change or modification prior maintenance operations. Proper documentation makes future maintenance relatively easy. In case the maintenance involves major changes, the system incorporating changes should be tested and user acceptance as to the workability of the system should be obtained. Source program library controls. The work efficiency of a computer system greatly depends on the software resources available in an enterprise. Computer hardware acts as body of IT infrastructure, and software is its brain and heart. It is therefore essential to plan the acquisition, use, and maintenance of the software required to achieve the information goals of the enterprise. As you know that in large computer systems such as mainframe, mini-computers, workstations that is servers, application are stored as object code on magnetic disk called source program library, that is SPL. Weak or inadequate controls in source program library may lead to threat to program integrity, unauthorized access, delay in production applications. A controlled SPL environment provides a protective environment. This requires the source program library management system, that is SPLMS, where protective features and procedures can be explicitly expressed. SPLMS is not only used to control following activities but also perform critical functions. These are: manages in-program storing on magnetic disk area for SPL, assist in retrieving programs for maintenance purposes, it helps in deleting the outdated, which are no longer used, programs from the library. It allows to document program changes. SPLMS provides security over program libraries. Audit trail and management report. The security violations from outsiders can always be controlled. The advantage of SPLMS is twofold. It enhances management control and the audit function. It does this by creating reports. These reports contain program modification details such as detail regarding additions and deletions in each module. Now these reports should be part of documentation file to form an audit trail of changes in program over the life application. During program audit, these programs are reconciled against program maintenance to check if required changes were actually implemented or not. This is useful when a legitimate user attempts to commit program fraud. The unauthorized changes in code would be reflected in program modification reports. These reports can be produced as hard copy or soft copy, which can be accessed by management and auditors. Program version number. Software versions keep changing every time the software package is updated to customize the need of the user. The SPLMS automatically assigns a version number to each program stored on the SPL. Initially, when a program is placed in the library, it is assigned a number 0. Subsequently, after each modification, the version number is increased by 1. This happens only when these modifications are duly acknowledged and combined with audit trail reports. An illegitimate change do change the version number on the production load module, but it cannot be reconciled to the legitimate changes signaled in reports generated by SPLMS. Controlling access to maintenance commands. Software tools available for SPL offer certain commands that may be used to control access to the library programs. These commands are used as maintenance commands that can be used to alter or eliminate program passwords, change the program version number, allow temporarily modification of a program without generating a record in report. These commands are used by system designers due to technical reasons. As a security measure, maintenance commands must be password protected and only licensed users should be able to access these commands, which is decided by security staff or management personnel. Message sequence numbering. Usually, security violations to information system occur at the desktop, but information is at risk of theft during transmission, that is wiretapping. There may be attempt of message being deleted, tampered, replicated, or unscrambled, difficult to understand. The solution to these risks is that message may be encrypted or sequence numbers may be inserted in each message at appropriate places so that any such attempt of violation will become apparent at the receiving end. Computer Center Security Controls. In this video, we are going to see about Computer Center Security Controls. Computer Center Security Controls actually involve securing both the data processing area and its equipment. Natural and man-made disasters can make many turns. Fires, floods, earthquakes, voltage fluctuations, security breaches, etc. can severely damage the computer resources of an organization. The objective of Computer Center Security Controls is to ensure that business operations will continue in spite of disasters. The following security measures must be adopted. Fire damage. Fire is a common encountered threat to a physical security of computer installations. Fire may completely destruct the computer center. Following steps should be taken to provide additional protection in case of a fire. Building in which computer center is located should meet high standards of fire safety. Walls and doors of critical areas should have a high fire rating. Fire alarms should be located at all critical areas. Smoking should not be allowed in the facility. Storms and floods. The following security measures may be adopted to reduce the risk of loss from storms and floods. Critical equipment should be placed in interior rooms away from windows, as windows can shatter during storms. Provisions for uninterrupted power supply should be made. First aid supplies should be readily available. Facility for adequate drainage should be ensured. Voltage fluctuations and power failure. Computers often suffer from several types of power inconsistencies and disturbances caused through power fluctuations and power failures. An uninterrupted power supply, that is UPS, is a backup power supply with enough power to allow safe and orderly shutdown of central processing unit in case of disruption of power. Computer systems may also be damaged due to fluctuation in voltage. For that, circuit breakers and voltage stabilizers should be installed to protect hardware against fluctuations in voltage. Disaster recovery plans. A disaster recovery plan is a method of restoring information processing operations which have been halted by distraction or accident. An effective plan should include the following elements. Emergency plan. Emergency plan describes the action to be undertaken when an emergency occurs. When an emergency occurs, decisions regarding the choice of action must be made swiftly and effectively. Recovery plan. Recovery plan is a written plan of action that enables a company to respond quickly to a disaster. It is a process of developing and maintaining an effective written plan of how organization will continue to operate in the event of interruptions of business functions. Backup plan. In spite of very stringent physical security in an organization, systems are always vulnerable to this disaster. Therefore, it is very important to have a backup of everything which can be destroyed. Recovery from a contingency depends on having the required resources available. Generally, backups are necessary for supplies, for example, customized forms, papers, tapes. Personnel. Facilities to house equipment as well as operation and support personnel. Hardware backup. Backup of physical equipment often provides a basis for other protection and backup schemes. Plan regarding hardware backup should include both on-site and off-site plans. On-site backup is contained within the computer center to ensure that resumption is made quickly with least disruption. Off-site backup is the process of storing records and alternate hardware at a location distant from the normal place of use. Software and file backup. The computer software programs and essential files or data must also be backed up. One or preferably two sets of duplicate records should be stored at a remote site or with a third party specializing in off-site storage. Test plan. The disaster recovery plan should be tested at periodical intervals to ensure that recovery procedures are complete and workable. Backup software, documentation, and data are adequate and current. Test plan identifies deficiencies in the emergency, backup, or recovery plan. Recovery plans may be tested at 3 different levels. Testing of offsite data and documentation to check the adequacy of offsite storage. At the second level, workability and adequacy of recovery procedures is checked. At the last level of test plan, ability to restore operations and processing of critical applications at the backup site is tested. Testing of disaster recovery plan. Testing ensures the effective functioning of the plan. Testing reflects any changes in operations, vendors, recovery strategies, procedures, and personal information from the time it was last updated. Testing also refreshes the minds of all the team members about the recovery process. Some of the components of the disaster recovery plan that should be tested are notification procedures, personnel availability and awareness, damage assessment procedure, inventory of off-site vaults, restoration of system and application software, insurance. Insurance coverage manages both risk and after the disaster because insurance with right endorsement is usually useful in compensating for disruptions in the business. This insurance policy should cover data processing system equipment, data processing media, valuable papers and records, business interruption loss, extra expenses on replacement, accounts receivable. Insurance coverage reduces the financial consequences of crime, fraud, and other damages. Internet and intranet controls. In this video, we are going to see about internet and intranet controls. Internet and intranet security can be defined as protection of network-connected resources against unauthorized disclosure, modification, utilization, destruction, incapacitation, or destruction. When an organization uses internet to engage in e-commerce, it exposes itself to additional security threats. A security threat may be defined as a circumstance, condition, or event with the potential to cause economic hardship to data or network resources in the form of destruction, disclosure, modification of data, denial of service, and/or fraud, waste, or abuse. Threats to the system may be due to the following reason: component failure, transmission of data among all other systems within a system, and also the transmission of data to other systems or receiving data from other systems is done through communication channels. Any communication channel poses the following threats: data may be lost or corrupted due to component failure. An intruder may intercept the data transmitted through communication channels. Subversive threats. The subversive threats may take following forms. Trojan horse. Trojan horse is a hidden malicious code that could alter or delete the information of client computer or perform any other unauthorized function. Sniffer programs. Sniffer programs provide the means to tap into internet and record information that passes through a particular computer while traveling from source to destination. Spoofing. Spoofing is the creation of illegitimate sites which appear to be published by established organizations. Web server threats. These threats reveal the contents of a server's folder's name to the user through web browser. Database threats. Database threats disclose or alter the information stored in database. Mail bomb threats. Mail bomb threats occur when thousands of messages are sent with the help of some program to a particular address, resulting in mail system to jam or malfunction. Controlling risk from subversive threats. In this video, we are going to see about controlling risk from subversive threats. Firewalls. A firewall is a set of related programs located at a network gateway server. The firewalls prevent outsiders from accessing the data behind the firewall. Some firewalls place a great emphasis on blocking traffic, while others emphasize permitting traffic. It helps in implementing an access control policy. A firewall is a system or group of systems that enforces an access control policy between two networks. Firewalls consist of specialized hardware and software that keep unwanted users out of a system. Firewall software filters incoming and outgoing information and blocks unauthorized users. The firewall systems are designed with the following objectives: access control at the network, access control at the user level, access control at the data level, access rights management, control at application level, alarm function. Types of firewalls. Conceptually, there are three types of firewalls. Network layer firewalls. Network layer firewalls consist of screen routers which generally make their decisions based on the source and destination addresses that are attached to incoming message packets. Application layer firewalls. Application layer firewalls are generally host running proxy server which permit no traffic directly between networks and which perform elaborate logging and auditing of traffic passing through them. Application layer firewalls can be used as a network address translators since traffic goes in one side and out the other after passing through an application that effectively masks the origin of the initiating connection. The application level firewalls tend to slow down the host computers. Advantages of firewalls. Firewall is an extremely powerful tool for providing network security. Firewalls can provide protection against attacks on individual protocols or application. Firewalls can be effective in protecting against spoofing attacks. Limitations of firewalls. Firewalls do not provide data integrity. Firewalls provide no authenticity of the source of data. Firewalls provide no confidentiality of data. Encryption. The original message is called plain text and the coded message is called ciphertext. Coding a message into a form that is unreadable to an interceptor is called encryption. Encryption serves the following purposes. Encryption prevents changing a transaction or message. Encryption impedes eavesdropping. Following are the encryption approaches. Private key encryption, public key encryption, private key encryption. When both the sender and receiver use the same key, it is called private key encryption. Public key encryption. A mathematical relationship exists between the public and private keys. They are related in such a way that only the public key can be used to encrypt messages and only the corresponding private key can be used to decrypt them. Callback devices. Login security should not rely only on passwords. When users access remote computers, a callback procedure should be used. A popular measure against unauthorized remote access is called callback. This procedure provides a high level of security and flexibility. Personal computer controls. In this video, we are going to see about personal computer controls. Personal computer controls. Computers owe their present-day popularity to personal computers, that is PCs. Before 1975, the use of computers was restricted to highly technical professionals and typically for scientific purposes. From 1977 onwards, personal computers not only achieved a significant market share but also firmly established as business equipment. With the advancement in hardware and software technologies, these computers have been found to be more useful in managerial activities. The strong acceptance of personal computers is based on following factors. Their complete hardware system, cost justified for acquisition by a wide variety of users. They support software that made creation of new programs relatively easy. Rapid diffusion of knowledge of small computers' capabilities and requirements for use. The modern personal computer's operating system is user-friendly and quite inexpensive. PCs add value to information by ensuring accuracy, consistency, completeness, and security of information. They provide efficient utilization of professional working time by performing a job such as information generation in a shortest possible time. Portable storage media, floppy diskettes. PCs are capable to work as standalone small computers, terminals to network computers, virtual office, office automation machine. PCs help in improving productivity, efficiency, quality of performance, and effectiveness in the work culture. The security risks challenges that concern the auditors are as follows. PC's portability. PCs being small in size may be shifted from one location to another or even taken outside the organization is a security threat to the system, that is PC, as well as its information. Portable storage media. Quite often, floppies are used as a convenient means of storage and transportation of information. This may result in misuse of information. Mishandling of floppy can cause damage or loss of information. Use of application software. Application softwares are generally not tested against security. Training of personnel or users. Computer staff not adequately trained for specific operations but do's and don'ts may corrupt the data files by mistake and may mishandle the sophisticated computer components. Computer virus. Using floppies from unreliable sources as opening undesirable files may harm the system and information by loading virus program. Security policy. Lack of security policy in an organization is a major threat to security. Security policy defines the duties and responsibilities of the employees. Security staff is a must in organization. Poor security solutions. Usually, inherent security solutions are not adequate to countermeasure security threats because threats are dynamic in nature. Decentralized purchases. PC comes in varying configuration in many makes and models. It may result in hardware or software incompatibility in the long run. Decentralized computing. As PC may serve as node in the network or work as standalone station or standalone PC, it is difficult to put security controls on individual machines. Weak access control. Any hacker or criminal may attempt to align the computer either from hard drive or from floppy drive, that is A drive, by booting the system by an uncontrolled operating system which ignores computer's stored operating system and security software. This may prompt the criminal to have unrestricted access to data and program residing in hard disk. Easily guessed passwords. The information may be at a loss if a person with malafide intentions guesses the password and accesses the computer. It is generally the tendency of the human to keep those passwords which they use most frequently, which are easily guessable. Moreover, they have the tendency to write the passwords in their diaries, etc. Inadequate backup procedures. In order to maintain the business continuity, it is desirable to maintain regular backups. Because PC environment is prone to disk failures, information may be accidentally deleted, but due to the user's lack of experience, training fails to appreciate the importance of backup procedure. In order to countermeasure the above stated security violation, the following controls may be implemented. These include procedural controls, PC peripheral security controls, access security controls, backup controls, logical controls, security policy, multi-level password control, training of employees. Procedural controls. In this video, we are going to see about procedural controls. Procedural controls consist of the following: PC, peripheral controls. Most computer equipment and peripheral can be quickly secured with steel cables, an easy and inexpensive theft deterrent. Special fasteners protect RAM chips and internal components. Cover locks can be used to lock the computer case, block access to disk drive slots, block access to CD-ROM, block access to on-off switch, floppies must be stored in secured places and access to floppies must be denied to unauthorized user. Antivirus programs first must scan any content or pirated software on a floppy. Floppies must be formatted before use and reformatted after subsequent use. PC drives must be cleaned and maintained regularly. Access security controls guard PC against improper use of equipment's data files and software. The old method of restricting physical access is with a lock. Locks are of following types: time lock. Access is denied to the system during specified hours such as normal business hours. Physical lock blocks access to floppy drives, CD-ROM drive. Programmable lock. Program resident in the computer's memory denies the access to unauthorized user. Backup procedures. In order to achieve the objectives, continuation of business service is important. As data is important to an organization, thus, in order to maintain integrity of mission-critical data, formal procedure of maintaining backup must be followed. In the PC environment, system crashes very commonly. There are a number of options available for taking backups. These are floppy disk backup. Floppy diskettes can be used to take backup and should be stored away from the computer site. This can be used in recovery of data in case of data loss. Dual internal hard drives. Personal computers can be configured with 2 physical internal hard disks. One disk can be used to store backup files and other disk may be used for routine work. The backup can be taken manually or can be software controlled, that is, it automates the backup procedure. This is advantageous over floppy diskette as hard disk can store large files. External hard drives. It is a removable disk cartridge which can store gigabytes of information or data. It is efficiently used for taking backups. When a cartridge is filled, the user can remove it and insert a new one. Tape backup. Magnetic tape is commonly used for archive purposes. These may be internal or external devices and provide efficient backup. It can store 1.6 GB of data. In a compressed mode, it can store up to 3.2 GB. Logical controls. In this video, we are going to see about logical controls. Logical controls. Logical controls include the following. Establishing a security policy regarding the following. Every organization should have a security policy that defines the limits of acceptable behaviors, duties and responsibilities of each employee. The centralized PC purchases should be coordinated and company-wide standards must be established for application softwares. Minimum standards must be set for developing and testing application programs. No playing of computer games on corporate PCs. No use of pirated software. Computer staff must be given training regarding do's and don'ts and managing security of the computer systems. Multi-level password control. Multi-level password control is used when users share the same computers to specific programs, directories, and data files. In this technique, stored authorization tables are used to restrict an individual's access to read-only, write-only, data modification, and data deletion capability. In this way, the technique of multi-level password control can greatly enhance the control environment of small organizations. Introduction to application controls. In this video, we are going to see about Introduction to application controls. Introduction to application controls. Controls that are designed to achieve specific control objectives can be termed as application controls. Application controls are specific controls unique to each computerized application such as payroll, accounts payable, and billing. They consist of both controls applied from the user functional area of a particular system and from programmed procedures. The objective of application controls is to ensure that the application processes all data and produces the desired output. These controls are implemented in the software and procedures of the information system. Application controls can be classified into 4 broad categories: input controls, processing controls, output controls, storage controls. Input controls. In this video, we are going to see about input controls. The input of data into a computer system involves the most probable source of error in such a system. The input function accepts data from outside the system to be processed in the system. Before data is brought into a system, it is acquired from a source called data capture. Generally, the data is captured by a person who writes the data on source document using codes. After capturing the data, it is accumulated in batches and put into the system, a process called data entry. When data is entered into a system, a program must check it for errors called data validation. Data validation prevents incorrect data to go beyond the data entry stage. When the data goes through the validation process successfully, then the system accepts the data and passes it on for processing. Input controls are implemented to ensure that all data entering into the system is valid and is properly authorized. Source data are recovered from all points of origin before processing is initiated. Source data are properly and accurately converted from human sensible to machine readable form. All original and adjusting entries are made into the system. All transactions are properly recorded at point of origin. Number of records keyed in tally with the number of actual records. Only authorized records are fed into the applications. Input is accurate and complete. Based on the various functions performed in input, controls can be implemented at various stages of input, such as source document control, data coding control, validation controls, input error correction. Source document control. In this video, we are going to see about source document control. The objective of source document control is to ensure that source data are recovered from its point of origin before processing is initiated and that all data entering into the system is valid. The following control measures may be applied at the source document point. Use pre-numbered source documents. Pre-numbered source documents provide reasonable assurance that only properly approved transactions will occur and the transactions will be documented at the point of occurrence. These pre-numbered documents should be accompanied with required approvals and reviews and evidence of the same. Source documents should be used in a sequence. This ensures maintenance of adequate physical security over the source document inventory. Source documents should be audited periodically. Audit tests should be periodically performed on data collection and data transmission equipment to verify the performance of the hardware and personnel. Missing source documents should be identified. Missing source documents can be identified by reconciling document serial numbers in the following manner. Total number of source documents used till date as per the sequence number of source documents. Total number of source documents processed till date. Total number of source documents in inventory as on the particular date. Total number of source documents voided due to errors till date. Total number of missing documents. Missing source documents which have not been accounted for should be reported to management. Responsibility should be fixed on person responsible for missing source document and appropriate action should be taken against him. Data coding controls. In this video, we are going to see about data coding controls. The data captured on source documents may not be in a machine-readable form. Therefore, before being processed, this data captured on source documents must be converted into a machine-readable form. Errors may occur when the data is keyed in, which may be in following form. Transcription errors such as adding of an extra digit or character to a code, removal of a digit or character from a code, or replacement of one digit with another in a code. Transposition occurs such as reversal of two adjacent digits. Check digits. Check digits technique is very effective in detecting transcription, transposition, and transmission errors. A check digit is a number or character that is appended to a primary key field. The check digit is calculated by applying a formula such as modulus 11 to the actual key. Modulus 11 is a very common self-checking digit technique used to verify that the original or source data has been correctly transcribed into machine processable form. For example, if an end user reads the key field value 241350, the number derived in modulus 11, and mistakenly keyed in the value 243150, the incorrect data could have been detected by applying the modulus 11 formula to the key values. The following procedures is used to assign a check digit to a key field. Step 1. Determine the size of the key field in digits. 24135 5 digits. Step 2. Number each digit location from right to left beginning with the number 2. 24135 65432. Step 3. Multiply each digit in the key field by its assigned location number. 2 into 6 is equal to 12. 4 into 5 is equal to 20. 1 into 4 is equal to 4. 3 into 3 is equal to 9. 5 into 2 is equal to 10. Step 4. Sum the products from step 3. 12 plus 20 plus 4 plus 9 plus 10, which is equal to 55. Step 5. Divide the sum from step 4 by 11. 55 divided by 11 is equal to 5, remainder 0. Step 6. If the remainder is less than 10, append the remainder digit to the key field. If the remainder is equal to 10, append the character X to the key field. There is a possibility that a transposition occur will not be detected by this technique. A check digit cannot identify those instances in which a valid but incorrect code is used. Validation controls. In this video, we are going to see about validation controls. The objective of validation controls is to ensure that transactions contain valid codes and characters and adhere to predetermined held sizes. Each of these characters is defined by the program in use and can be compared to the input as it enters a given process. When data is entered into the system, it is checked by a program for errors. This process is called data validation. It involves checking of all input data for all possible errors. If the data passes all validation checks, the system accepts the data and passes it on for processing. Incorrect data which fails to pass any other validation checks is not allowed to go beyond the data entry step and is rejected by the system. The input can be controlled through validation checks at 3 different levels: field interrogation, record interrogation, file interrogation. Field interrogation. Field interrogation is programmed procedure to examine the characters of the data in the field. Some of the field interrogation procedures are limit and range checks. Limit checks, sometimes also called tolerance checks, are programmed into the system to call attention to any data that exceeds or is less than certain pre-designated limits. This check does not ensure that the data is valid, but only ensures that it has not exceeded the stated parameter. Picture checks. Picture checks compare data entered against the known COBOL picture defined for that data. Transaction validation. In some cases, the complete set of data may be valid, but the transaction itself may not be allowed. Valid code checks. Valid code checks are made to ensure the validity of input data. This technique is also called edit checks. Arithmetic checks. Arithmetic checks are performed to ensure the validity of the result of other computations of the values of selected data fields. Cross-checks. Cross-checks verify fields appearing in different files to ensure that the results tally. Record interrogation. Record interrogation consists of the following checks. Sequence check. Sequence checks are made to ensure that the data is arranged or ordered in an ascending or descending sequence prior to processing. These checks are a very important part of the file update process when the file is organized in a sequential or serial mode. Format completeness checks. A completeness check is made to ensure that the desired information is included in all the data fields in the record and that all input is included in sequence. Combination checks. Combination checks are performed on a record or on several input items to determine their logical relationship and to remove any erroneous combination of data. These are also called relationship checks. Passwords. The password is a pre-established key used to identify a user and his right to access a given file. The passwords consist of numbers, letters and symbols which identify an authorized user and his terminal location. File interrogation. The objective of file interrogation checks is to ensure that the correct file is processed by the system. These checks are more important for master files containing permanent records. The important file interrogation check is external label checks. Another form of control over input is provided in the use of external labels which are visibly written on any tape of data container. Such labels usually contain information such as serial number, length of tape, name, date of run, date of last work processed, output tape address, the number of the runs to be used in conjunction with, and the tape address for each of these runs. Input error correction. In this video, we are going to see about input error correction. The errors detected in source documents should be corrected and subsequently reprocessed. A controlled process ensures that errors have been dealt with correctly. The various error handling techniques are immediate correction. In the direct data validation approach, error detection and correction can take place simultaneously during data entry. The system should halt the data entry procedure upon detecting a keystroke error or on detection of an illogical relationship. The user may correct these errors at this stage. Delayed correction. Errors found in batch processing with sequential files should be flagged to prevent them from being processed. The records flagged as errors should be removed from the batch and are put in a temporary file until the complete investigation is made. Reject the batch. Errors may be associated with the entire batch. Processing controls. In this video, we are going to see about processing controls. Processing controls. The objective of processing controls is to ensure that the processing of input has been done correctly. The processing controls ensure the completeness of data processed by the computer, the accuracy of data processed by the computer, that all data processed by the computer is authorized, the adequacy of audit trails, processing errors are analyzed and corrected, transactions are not lost, added, duplicated, or improperly changed, proper documentation explaining the processing of each application program, securing application programs against direct input from console, that output counts from the system tally with the input counts to the system. The most common forms of processing controls are cross-footing. Cross-footing technique utilizes addition and or subtraction of horizontal row or vertical columns of factors or elements in order to prove processing and posting accuracy. Edit checks. Edit checks check the input or output data against predetermined codes, conditions, or standards. These checks are used to ensure data compatibility, not data accuracy. Zero balancing. Under this technique, the accumulation of a given quantity or amount field is subtracted from a predetermined beginning balance so as to arrive to a zero balance. Any balance other than a zero would indicate an error condition. Existence checks. Existence checks are used to determine whether a tested code is active, acceptable, or valid. Sequence check. Sequence checks are made to ensure that the data is arranged or ordered in ascending or descending sequence prior to processing. Completeness check. Completeness check is made to ensure either that the desired information is included in all of the data fields in a record or that all input is included and in sequence. Reasonableness check. A reasonableness check is a test made on a field to ensure that it has not exceeded a predetermined parameter. Date check. Date check is used to check input records to determine whether they are acceptable on a given date. Housekeeping checks. Housekeeping checks are performed at the beginning of each computer processing to clear buffers, clear registers, reset program switches and bit masks, initialize areas, etc. Transaction logs. Transaction logs represent a technique for recording events occurring on a computer. These logs can be used to record users' identification, the files they accessed, and type of inquiry. Transaction logs serve the following objectives. Transaction log is a permanent record of transactions. Transaction log records successfully processed transactions. The unsuccessful transactions are recorded in an error file. Transaction logs can be used as a control and balancing tool. Transaction logs can be used as an aid in reconstruction if necessary. Transaction logs can also aid the auditor without additional expense to the installation. Transaction log can serve as an excellent audit trail. Audit trail controls. In this video, we are going to see about audit trail controls. If the log of transactions contains detailed information about each transaction, it can then be used for audit trail purposes as well as for control purposes. The use of an audit trail may vary depending upon the user. For the installation itself, the audit trail may more properly be called a reconstruction procedure. These records provide a means to the auditor by which results can be traced back to their original transactions. The calculation of control totals for data control can be combined with the generation and use of normal activity reports. A transaction listing can result from a logging operation in real-time systems or can be produced in a batch mode application as a part of the control total balancing operation. This transaction listing can also serve as an accounting or managerial report. In batch mode operation, the total of this listing can be compared against a batch control sheet on a daily or batch basis. At the end of an accounting period, the control sheets can be used to balance against the master files. Real-time systems can also accumulate and produce transaction listings or logs that can serve the same function. In a real-time system, however, the balancing of transaction totals to master totals can be done continuously and automatically by the computer. Further, the control record can be generated by the system itself. Output controls. In this video, we are going to see about output controls. The objective of output controls is to ensure that the output of a run application is accurate and complete. Output controls are developed and implemented to ensure that reports and outputs are accurate, that no unauthorized entries to the system have been made, that detected errors and exceptions have been corrected, that outputs and reports are in proper format, that reports appear in human sensible language, confidentiality and integrity of output, labeling and timestamping of each output, methods for reporting, correcting and reprocessing outputs, that is, dealing with exception reports. Output controls are primarily procedural checks. They are more difficult to establish because they are affected by the intermediate processes performed between input and output. The various types of output controls are: totals. The output total control is determined primarily by the available input control totals. The totals generated at the initiation of the information processing cycle may not be identical with those outputted. Checkpoints and restart procedures. Checkpoints are included in the system to check whether processing has been accurately performed up to a given point. Setup procedures. The setup procedures are designed to ensure that output of user reports is in a proper and meaningful format. Sampling. Statistical sampling techniques may be used to check the reasonableness and accuracy of output. Console operating procedures. The objective of console operating procedures is basically to provide the necessary operator instructions. Use of pre-numbered standardized forms. Use of pre-numbered standardized forms is another form of output control. Non-standard or modified data forms will not be compatible with standard forms. Storage controls. In this video, we are going to see about storage controls. The objective of storage controls is to ensure that correct data is stored and accessed. An example of storage control is a data access control, in which anyone needing access to stored data must go through the database administrator, that is DBA. The DBA provides all information regarding how to access the data, including file or database names and special access codes. The file or database software checks the names and codes to ensure that the correct data is being accessed. Following are the important storage controls. Field checks. Field checks are tests for appropriate values in a position or action. Field checks may be performed tests for numeric, uppercase, alphabetic, or a given set of acceptable characters. Field checks are made to check for simple errors while entering the data. Change logs. Change logs carefully log every change made to the system containing both the original and the new values. User authentication. User authentication means that all entries and actions should be checked to ensure that user is authorized to access not only the database but also the individual files and information. Audits. Internal and external audits ensure that the system is performing as designed. State constraints. If state constraints that describe the condition of the entire database are not met, some value of the database is in error. A flag can be used to denote a constraint violation. Monitors. Monitors can check values being entered to ensure their consistency with the rest of the database or with characters of a particular field. The structural integrity of the database should be monitored. Suppression. Suppression occurs when, in a query, sensitive data values are not provided and are rejected without response. The query is terminated without any indication of what data or values exist. Concealing. Concealing occurs when, in response to a query, the response provided is close to but not exactly the actual value.